Today's agenda will begin with load path continuity, look at the building code updates, and then finish with our shear wall design alternatives, including the shear wall research that I mentioned a moment ago. Building code says that we need to make sure we provide a complete load path using rational analysis that's capable of transferring the loads from their point of origin to the load-resisting elements. And this needs to be done in both the vertical load path as well as our horizontal load path. And the horizontal load path, as we can see just by this quick, simple diagrams left and right, is that the horizontal load path is more circuitous in nature. It's not as direct as our vertical load path, and therefore there's opportunities for a lateral load path failure to occur more readily than a vertical load path. So a little humor to begin our webinar here today. You'll notice that we have an incomplete load path shown in our vertical direction, clear to see, whereas our lateral load path takes more study and experience. So you need to begin by looking at where are you constructing and designing this structure. And here we have the FEMA hazard maps to shed some light on the lateral loads that are going to be most important in your design process. On our left-hand side, we have our wind hazard map, and unlikely a surprise to anyone, we see again this red zone through the middle of the country, aka Tornado Alley, as well as our shaded zone on the southeastern portion of the United States, where hurricanes are more prone. On the right, we have our earthquake hazard map, and again, a red zone on our west coast representing very high seismic loads. And you may, if you're a West Coast person, may not be aware that there are other seismic regions to be concerned with, such as the New Madrid Fault in southern Illinois, as well as in the southeast. Useful to consider these loads in the most basic form to understand the impacts of why the code says what it does and influences our design choices, particularly when you look at conventional construction requirements. Many of the conventional ideas take this into account. So first, when we look at our wind force, that force is equal to the wind pressure times the surface area. So as your structure becomes taller and larger, individual segments of the walls go from 8 to 10 feet in height, you of course will have a greater force that you're going to have to design to resist. And our wind loads are designed in accordance with ASCE 710, referenced from Chapter 16 of the Building Code. For our lateral loads regarding seismic or earthquake, that force is equal to the ground acceleration due to the earthquake times the building mass. So again, your choice in building materials are going to impact the force you have to resist. The more mass of your structure, the larger the force. And so when we are considering wood frame construction, this is important to remember. A benefit of wood frame construction is that it does have a high strength to weight ratio, so that's very useful in being able to efficiently design these buildings to resist the force. Yet in California in particular, we have a trend for using a lot of concrete tile on our roof, which will again increase the mass of the building materials and impact our design. And if we were using brick veneer as an alternative as well to stucco, that would increase the mass of our wall section. So again, thinking about these very basic formulas will help us when we're thinking about our design effects. And so the next item I'd like to share with you is some photos that we've collected over the years that demonstrate our general modes of failure, uplift, base shear, racking, and overturning. One of the items that APA provides for services, when there is an event, a wind event or earthquake, we send out our local field rep when feasible to take photos, write a report. We have several publications on our website that have come out of these research or investigations following tornadoes, Hurricane Katrina, for example, that you can refer back to in the future. And in my experience, when I started with APA, I actually began working in Chicago. A lot of opportunity, of course, to look at wind events, and did go to view damage after 2 tornadoes in Springfield, Illinois, as well as southern Wisconsin, and it really reinforced what I had always known via the building code and what I had implemented in my designs in the past as well.